Morning, everyone. Before we get started on Amazon Athena, a quick introduction about Solution Street where I work. We are run by software engineers. Most of our clients are commercial clients. You will get a chance to work with best engineers across all tech stacks. Our company headquarters is in London, and we are hiring. I think the recent openings are in .NET and UI developer. If you would like to know more about us, please reach out to me or my colleagues. All right, so let's get started on Amazon Athena. Why? So it's all about big data analytics. Yeah, it's all about big data analytics. When there is a need to analyze large amount of data which is in terms of terabytes, petabytes, these tools can be used. In fact, tools like Hadoop data warehouse can handle even larger workload. The challenges with these tools are there is a need to provision resources, configure them, fine-tune them, and data needs to be loaded before it can be analyzed. Of course, a managed version of this tool where cloud service provider takes care of most of these challenges, resources still needs to be allocated and paid for. Basically, managing the data could be expensive, and data needs to be loaded before it can be analyzed. Relational database, it's a misconception that relational database can't be used for analytics. It can very well used depending upon use case, but the challenges are similar where resources needs to be allocated and paid for or managed. NoSQL database can store very large amount of data, but it is designed for very specific use case. When the key is known, data can be retrieved in terms of millisecond. In order to perform analytics, a scan operation needs to be used. And depending upon cloud service provider, there could be tons of restriction on the scan operation and it can be expensive. The non-managed version of NoSQL database, it will have similar challenges in allocating resources, configuring them, fine-tuning them. There are other tools that can also do analysis of the large data set, but they will have similar challenge. The point here is when large data set needs to be analyzed on an ad hoc or infrequent basis without commitment on resources, without complex and time-consuming configuration or setup, without loading the data itself, Amazon Athena can help. So let's see how. Amazon Athena is an interactive query service that makes it very easy to analyze data using standard SQL. It's a standard SQL. That means like there is no learning curve. We can use our existing knowledge about SQL to analyze the data. Serverless, there is no infrastructure to manage or set up. Just start analyzing the data immediately. There is no need to load data into Athena. Amazon Athena can analyze the data where it is stored. You just need to define your table schema and start querying. In case of Amazon ecosystem, Amazon S3 is the most common storage solution. You can think of Amazon S3 as a kind of file system where files are stored. Apart from Amazon S3, Athena can connect to relational database, NoSQL database, data warehouse, and there are many other tools that Athena can connect to. One thing I would like to clarify here is Amazon Athena is not a relational database. It's a distributed query engine that makes it very easy to analyze data using standard SQL. So let's do a quick demo. I'm using two different set of data. One is like the product. Let me get my mouse. Okay, I got it. One is the product list and the second is user product mapping. For the presentation, I already uploaded them to the S3 bucket. So as I mentioned, Amazon S3 is a storage solution where data can be stored. So this is first data set. I have uploaded two CSV files. This can be thought of as data that is exported on a regular basis. Daily, weekly, monthly, it's a growing set of data. The second data set is just single CSV file. And this is the storage service basically. So data is already there, and let's see like how we can analyze that data which are already present in Amazon S3. So this is the AWS console. There are other ways, like there are APIs to execute Athena queries, but this is AWS console using which we can run queries. So even though this looks like a SQL which is creating actually a table, again, Athena is not a relational database. This is just a way to tell Athena where the data is stored. As you can see here, this is the location of our data. Excuse me. And this is the format of our file. In this case, it is a CSV format, and this is how data is organized. So I already created this table for the presentation. So this is our first list. In this case, we have more than one file. So we pointed to the top level directory. The second one is single file, and this is the content of that particular file. We need to specify the name and type and what kind of file format it is. Now, once we define this table, so again, even though this is a SQL table, behind the scene, Athena is creating a catalog inside AWS Glue service. It's transparent to us. Amazon Athena takes care of all the stuff. So now let's run some queries. So this is the query that is running against our first list. And let me scroll. In this case, the data was spread across multiple files, and that's what we retrieved. And this is our second set where user product mapping was stored. And this is the join demo. So you can see that this acts as if like we are running query against relational database. Again, Athena is not a relational database, and we can write as complex query as we want as long as it is following the SQL standard. Athena has full support of the SQL standard. So I will pause here. Anybody has any question on the content that was presented so far? All right. So now let me get back to the presentation. This is just a screenshot. All right. So Amazon Athena is a flexible, scalable, and cost-effective solution for analyzing large amount of data. Now, there are many use cases, but like these are the typical use case. As you can imagine from the demo, how quickly and easy it is to start analyzing the data. For example, before setting up ETL pipeline, if we want to see the dump, how good that dump is, data dump is, whether it's in hundreds of gigabytes or terabytes, we can easily use Amazon Athena on an ad hoc basis to just sanity check the dump that we are receiving. And that makes it perfect use case for ad hoc analysis. Log and event analysis. If you have worked in Amazon ecosystem, the load balancer logs are available in Amazon S3, but unfortunately, Amazon doesn't ship it to CloudWatch, and that means like you can't search it. In such scenario, Amazon Athena, what you have to do is just define the table schema, and now like all your access log for the load balancer is searchable and it can be analyzed. Similar to load balancer log, like any other logs or events can easily be analyzed using Amazon Athena. Data lake analytics. Data lake is a specific term used in Amazon ecosystem where data from multiple systems are exported into Amazon S3, which is a storage solution. And that can, with Athena, it can act as a minified version of data warehouse, but at a lot less cost and lot less work than we would be doing with data warehouse. ETL and data transformation. Perfect tool for transforming the data, filtering the data. Cost-effective data exploration. There is no upfront cost. With Amazon Athena, you only pay for what you use. Compliance and reporting. Say, for example, all the internal system logs or events can be sent to Amazon S3, and with Athena, it can easily be analyzed for compliance, and a workflow can be automated for reporting purpose. Not only that, Amazon Athena itself can be audited, like who is running the query, what data is being accessed with little configuration. And these are all different tools that Amazon Athena can integrate with in Amazon ecosystem. Amazon Athena has a native support for Amazon S3. So you don't have to do any additional configuration other than while creating a table schema, you just need to specify the location. For other data sources, a little bit of configuration is needed to connect, but Amazon S3 is the most and regularly used storage solution, and it has a native support for Amazon Athena. In this diagram, like there are data warehouse, operational, database, ERP, like all can be connected to Athena. Athena can also be connecting to BI and analytics tool for the visualization. So how does Athena work? So Amazon Athena is a wrapper around tool called Trino. Trino is a distributed query engine which can process the data in parallel across multiple servers. Now, Trino itself is a spin-off from the Presto. Presto was originally developed at Facebook in order to replace Apache Hive in order to process hundreds of petabytes worth of data that Facebook had back in 2008, 2009. Over the time, the conflict of interest arises between the developer who originally created Presto and the management. So they decided to leave the organization and they forked the Presto, and later it was named as Trino. Please take these details with little grain of salt because these details are not available easily online. Amazon documentation is silent on how internally it works. So I collected these details from the third-party articles. As a bare minimum tool, Trino, these are the advantages and disadvantages. So Trino itself is a SQL compliant query engine. We can use full set of SQL syntax to analyze the data. It's cloud focused, so it was built with scalability in mind. And agnostic data source connection. That means it can connect to a variety of data sources. The disadvantage as a bare minimum Trino is there are lack of enterprise features like security access control. There is a little support for data encryption. There is no support on like who can access what data using the Trino as a bare minimum tool. And if we need to use Trino as a bare minimum tool, we are looking at configuring it, setting it up. And by default, Trino is optimized for read-only or for analytics purpose. Again, this diagram was not available on Trino website itself. I couldn't find any article where like this diagram could be present, so I took it from Wikipedia. And this is how internally the Trino works as a distributed query engine. Luckily, we don't need to worry about the internal working of the Trino because Amazon Athena make it everything transparent to us. I'm just checking in case anyone has any questions. All right, we'll move on. Okay, so in the demo, I have used CSV files, but apart from CSV files, like there are many other file formats that Amazon Athena can work with. Notably, the ORC, Parquet, and Euro, those are binary file formats. It has capability to compress the data. ORC and Parquet file formats are column-based file formats. So in database, we store the data at row level. This is opposite of that where column-based data is maintained in ORC and Parquet. Euro is a binary format that stores the data in a row format. Of course, we can still analyze the CSV, JSON, and other file formats. So how does Athena knows how to read the files? That's SERDE, serializer, deserializer. While defining table schema, we need to specify which serializer, deserializer is being used. Athena has support for these popular file formats and many more. So this tells Athena how to read, how to deserialize. That's where the deserialize comes into picture. And once the result is available and it needs to be stored, it needs to be serialized. And that's where these libraries help. Unfortunately, Athena does not support the custom SERDE, so you can't come up with your own one. You need to choose from whatever is made available by Amazon. Athena is a schema on read query engine. So while defining the table schema, Athena is not going to go and examine the file content. So you can perfectly say whatever number of columns are there, whatever type it is, it's not going to complain. Only thing it's going to check is whether the syntax was right while creating the table schema. It's just a metadata, lightweight data about how the file is organized. But when it tries to read it, it needs to actually deserialize the data, and that's when like you might get an error if it was not defined correctly. For example, like more columns were defined than what's actually there in the file. Athena does not modify the actual data, and that's the reason that Athena has the capability to analyze the data where actually it is stored. We need to be careful while choosing the file format if we are looking at our schema evaluation. If you are looking at a use case where data is regularly exported on a daily, monthly, or a fixed cadence, whatever that may be, then we need to be careful with the schema, because some file formats are flexible about schema evaluation while others are not that flexible. If we anticipate a frequent schema change, I think Avro is best suited for that one. ORC and Parquet has limited flexibility. Again, JSON is most flexible, but again, like that might not be efficient for particular use case. So if the schema is going to evolve over time, just be careful about which file format is being chosen for data analysis. If we are doing ad hoc analysis, or we know that like we are always going to get new set of data, like we don't need to worry about schema evolution, because at that point in time we can always define the latest schema. In the past, this is how I have used the Athena. So you can imagine it's a data lake formation where data from multiple systems were exported to the S3, and there is a consumer application which ran the complex SQL queries to generate the report for the business user. RDS snapshot, so Amazon has a terminology or the feature where daily snapshots are automatically taken, and this export to S3 service is a service offering from Amazon itself, which can export the data from the snapshot against the live database. So we are not touching the live system. We are pointing to snapshot, and from there data is exported to S3, which can later be analyzed by consumer application. The driver for choosing Amazon Athena was we don't want to overload the live system. These were complex queries running across multiple systems. None of the system had read replica, so basically adding one would add to the cost. And this report is basically generated maybe 10 times per month. So we don't want to use data warehouse where like if it is not existing, like we need to set up one and it's an ongoing cost. Versus Amazon Athena is a perfect use case where like we just need it on an on-demand basis, on a less frequent basis. We talked about export to S3, so Amazon has a service which allows to export the data from the snapshot to the S3 bucket. By default, I think it exports in Parquet format. It's a binary file format. What we learned, which is not easily available on Amazon Athena documentation anywhere, was yeah, bit data type, of course, like no, it's not a SQL standard, but like we were using one and it was not supported. It's not that Amazon Athena was failing. It is just that like we need to come up with workaround to make it work with bit data type. Elasticsearch connector didn't work for us in a way that we wanted. And frankly, we didn't explore much because we found the data in another system. So we didn't explore much on the Elasticsearch connector. The default timeout was 30 minutes. So if you are analyzing very large data set, it's quite possible that Amazon Athena can time out. Of course, this is account level default timeout. It can be increased. And the most important one was that query execution is asynchronous. So basically, like once you issue the query and if there is no syntax issue, then you are going to get the ID and now you need to keep polling it to understand whether the result is available or any issue occurred. Plan for retry. Basically, Amazon documentation itself recommended of built in the retry capability for Amazon Athena. And the reason is Amazon Athena is a, I think, region level SAD service where all other users are using it in parallel. So it's quite possible that if it is overloaded, your query might not get enough resource to be executed in a given amount of time, and Amazon will return an error and it can be retried and next time it will just work fine. For all practical use, we haven't encountered such error yet, but Amazon recommended building the retry capability with Amazon Athena query. This is specific problem to us because we are using export to S3 service. That means each time we do export, it's a fresh set of data. It's not a delta. So every time we need to work with the new set of data, and the table schema that we created previously didn't allow us to repoint to the new set of data that we created recently. So that means every time we export latest data, we need to rebuild table schema. Of course, it's a lightweight, so not an issue, but just something to be aware of. And I was surprised that it does support ACID transactions. For that, you need to use specific tables and specific configuration. Those are iceberg table types. But yes, at table level, Amazon Athena supports ACID transaction where concurrent user inserts and updates are taken care of and ACID properties are supported. Cost model. So it is pay as you go. There is no upfront cost or no commitment on the resources. Just pay for what you use. By default, the Amazon Athena charges $5 per terabyte of data that is being scanned by the query. So you can imagine, depending upon data size, like this could be very cost-effective solution. The downside is, as I mentioned, we need to build the retry capability in case like Amazon Athena is overloaded and we need to retry it. If you don't want to do it, if you are running very important workflow and it has to get priority, Amazon supports provisioning capacity. That means Amazon Athena will prioritize the workload for the query for which the capacity is reserved. And for that, like a fixed amount needs to be paid if we opt for the provisioned capacity. Now performance. Of course, we are analyzing hundreds of gigabytes, terabytes worth of data. We would like to save the cost because cost is based on amount of that data that is being scanned. So some of the techniques are, if you are using CSV or JSON, try to switch to the binary format. It has a compression support, so storage cost is reduced. And specifically the binary format, which is column based, and if you don't need all the columns from the file, basically you are saving a lot. Amazon Athena also support looking at the execution plan, how exactly it's going to analyze the data. In turn, it allows you to refine your query. Include only the required columns. So if you need only, say, 5 out of 15 columns, just retrieve only those columns and it will save a lot. And it also improve the performance. And at the end, yeah, of course, like we can always go back and rewrite our complex query in order to improve the performance. So these are all the enterprise features that Trino, we were talking about, the tool that was lacking. Amazon Athena has those support available because it's a wrapper, and then we done this tool to be used as an enterprise tool. So all this promise comes from the fact that Amazon stores the result in S3, and S3 storage solution has this capability built in, basically, and that's the reason Amazon Athena is offering one to us. Scalability, elasticity. Trino itself is built on the premises of scalability. It was built from the scratch for scalability in mind. Security, authorization, encryption. When the data is stored in Amazon S3, there is lots of control that is available. Data can be encrypted, access control can be applied against the data who can read it. Not only that, the result which is stored in Amazon S3 can also have similar access policy applied regarding whether we want to encrypt the result and whether like we want to restrict access to the result. Apart from AWS console that I have used for the demo, there are APIs available, CLI available. CLI is like command line tools using which we can query API for different languages. And yes, apart from Amazon S3, if you are trying to looking at connecting relational database or any other data source, you are looking at using Athena federated query. These are the Amazon SDK available, and it executes as a AWS Lambda to connect to the data sources like relational database, data warehouse, and whatnot. All right, so questions? I'm not sure about the JDBC API, but I have definitely used language-specific API. In my case, I have used Java-based API. All right, then, thanks everyone.